A very good day to the panelists of the National Conference on TVET undergraduate students and my fellow watchers. My name is Raj Kumar and I'll be presenting my paper on e-missionary organizer with cloud storage application. The contents that I'll be presenting today include introduction, problem statement, objective of the project, scope of project, methodology, result analysis, project cost estimation, conclusion, originality, innovation or solution of the project, and also the recommendation. So now I'll begin with the introduction of my project. So here I'll be speaking on what motivated me in order to carry out this research. So according to MZ Ramli, project delay is categorized as a major component of construction management process and has become the key factor to gain success in a project. Delay in construction projects such as increased cost, extension of time, dispute between parties are such negative impacts that are giving adverse impact towards the construction industry. So this eventually leads to slow progress in a project, and at a longer run it causes cost and time overrun. By using IoT, the project lifecycle becomes more manageable, especially in monitoring and controlling the machinery, material and labor usage. So the integration of IoT, according to the fourth industrial revolution, such as advanced robotics, cloud computing, cybersecurity and big data analytics, is important in monitoring and controlling the whole project lifecycle in the current era. So what was the problem that led me to carry out this research? So earthwork construction requires many machinery for purpose of site clearance and also infrastructure work. In order for site progress to be on schedule, machinery management is very important. So the current method of managing machineries is through a supervisor who arranges the machineries through the instruction of the project manager. During peak work schedule, when machineries are arranged, the information is not sent to everyone due to a hectic work schedule. Everyone is busy with their own work. Next, I'll be speaking about problem statement. In my problem statement, I have identified 3 previous researches that is somewhat similar to machinery tracking, but it's not the same. So the 3 researchers that I found uses RFID technique, mobile computing device and wireless technology, as well as Internet of Things to track items of their choice. So what I found out is that RFID trackers, the issues with RFID trackers is that once you use RFID trackers, they use a certain form of sensors. So they provide issues as time passes by due to the wear and tear of the sensors, and to install sensors in heavy machinery such as trucks, excavators and bulldozers, for example, the sensors are definitely due to wear and tear due to the sophistication of the device as well as the way they work. Next is real-time tracking. So in one of the previous studies by Amin, they used real-time tracking to track construction work progress. So real-time tracking solution is dependent on GPS positioning. So GPS positioning, basically it does not work or function steadily during bad weather conditions. Even if you take in consideration our normal phone line is somewhat similar, and we don't get a good reception when the weather is bad. So same concept goes to this as well. So in my case, in my application, I provide location of machineries based on a site layout. I do not do real-time tracking or also use sensor. And also I provide details of Moving on, I was speaking about the objectives of my project. So the first objective is to design an e-machinery organizer application to improve machinery management at the construction site in accordance to IR 4.0. The second objective is to develop the e-machinery organizer application using Adalo application developer. And the third objective is to test the effectiveness of e-machinery organizer in the construction site. Furthermore, I'll be speaking on the scope of the project. So the scope of this research is limited to the construction site area of Kota Elmina Business Park. So this application will allow project managers, site engineers and site supervisors to manage the machineries at the project site. So the application will be categorized into two, which is one is the user interface for project managers and site engineers, and also the administrator interface. Next is the site supervisor will be able to locate and state the location of machineries and label them in the application. And this application will use cloud storage such as a Google Drive to store data. In order to try my application that I have developed, you can try to scan the QR code as attached to the slide. You can choose to create your own account, or you can use my already registered account below, which is turay.9748@gmail.com, and the password is as below. And you can try logging in, and I'll explain the whole application in the next slide. Okay, next I'll be speaking about methodology. Under methodology, I'll first speak about development of research. So the research is divided into two phases. My application is divided into two phases, which is administrative interface and also user interface. An administrative interface allows the admin to make changes to the app, and the user is only allowed to see the changes to the app. So first, it will begin with the main screen, whereby it's divided into the administrator and user login. So this is for security reasons. Moving on, in the administrator interface, the admin will be able to edit machinery location, operator details and tasks according to the daily needs at the site. So moving on, machineries are labeled according to different symbols and colors in the site layout, and when clicked, it will display the operator details. The edit screen will enable the administrator to edit all the details regarding operators and tasks at the related location in the site. The edit location interface enables the administrator to also move the location of the machinery according to the needs at the site. So the admin will be able to change the location, the symbols, the operator details, and also any related changes, including the task in the administrator interface. So in the user interface, the symbols will indicate the location of different type of machinery at the site, and when clicked, it will reveal the details of operators and task at hand. Next, I'll be speaking about result analysis. So the researchers has taken 30 respondents. I have selected 30 respondents, and the questionnaire is based on the technology acceptance model by Davis, and the analysis is made from the social science statistics website to analyze the t-test and the two t-tests, double t-tests. Okay, so the data collected was the pre-final year project questionnaire and also the post-final year project questionnaire. So in the pre-final year project questionnaire, we analyzed the respondents' view in the existing method to monitor machinery at the construction site, and the post-final year project questionnaire is to analyze the effectiveness of the application, e-machinery organizer application that was created by me. Moving on, I'll be speaking about data analysis. Firstly is respondent background. So the respondent of background was completed by employees of Pembinaan Tetap Teguh Sendirian Berhad, Khairi Consultant Sendirian Berhad, and also Saim Dabi Properties. So a total of 30 respondents comprising of 19 male and also 11 females. This slide provides evidence to the survey conducted to identify effectiveness of existing method on machinery management at the construction site. So the pre-FYP questionnaire consisted of questions regarding the respondents' acceptance towards the old conventional method of machinery management. From the data, it can be seen that majority of the respondents feel that the current conventional method is not suitable. Majority of the respondents indicate on scale 3.0 and below, more than 50% agree, which is the respondent agree that the existing method was ineffective. This proves that the current conventional method is not useful and there is dire need for a solution to be brought in. Next is the data that survey to identify the effectiveness of e-machinery organizer at the construction site. The post-FYP questionnaire consisted of questions regarding the respondents' acceptance towards the e-machinery organizer at the construction site. From the data, it can be seen that majority of the respondents feel that using the e-machinery organizer at the construction site is suitable. Majority of the respondents indicate on a scale 3.5 and above, in which more than 50% agree, which is the respondent agreed that the e-machinery organizer was effective. This proves that using the e-machinery organizer at the construction site is useful. Finally, a paired sample t-test was used to identify the difference to be significant for all variables being measured. So the value of t of the perceived ease of use is 12.73 and the value of p is less than 0.0001. The result is significant at p less than 0.05. The value of t for perceived useness is 15.99. The value of t of attitude toward using the technology is 13.53 and the value of t for behavior intention to use is 16.15. All this result is significant at p less than 0.05. This suggests that the using e-machinery organizer was much easier and resourceful compared with existing method. This means that the e-machinery organizer was more effective compared with the existing method. Following is the project cost estimation. So the total amount of this project was about 124 ringgit, coming with a Dalo application coming in free and the banner and the thesis about total of 124 ringgit. In conclusion, the project that is possible to say that the respondents have problems in managing machinery at the construction site. The respondents have also agreed that all of the issues pertaining to machinery management at the construction site can be solved by using e-machinery organizer with cloud storage. This project was proposed for the use at Kota Elmina Business Park in Sungai Buloh because of the various machineries that had to be managed in the project. The effectiveness of this project was tested by using the PET-T test method by social science statistics, and all of the objective of this project was achieved. Next is the originality, innovation and solution of the project. So the conventional method, supervisors need to be present in order to locate the machinery. Planning does not include the whole project team. Machine operator details are not with everyone and no notification in the event of machinery breakdown. So what are the benefits of e-machinery organizer? In the absence of supervisor can arrange machinery through application. Planning of machinery can be known by all. Machine operator details and location are present in application, and machinery notification, details of breakdown and target repair date can be obtained from this application. Finally, moving on to recommendation, it will be much useful to many parties if the application can cover various other projects carried out by the company. Currently, this application is used by the project department to manage machineries at construction site. Maybe other departments such as QA/QC, admin, procurement and quantity surveyor can use this application to store their documents through cloud storage. Application can be created using other software such as Google Flutter, Jira, MIT App Inventor and Unity 3D. Users can create the application using platforms as mentioned above. The current scope of this project is Kota Elmina Business Park. Therefore, it will be much useful to many parties if the application can cover various other projects carried out by the company. That is all from me. Thank you very much for listening to my presentation and hope you all have a great day.